Okay, so now continuing with the topic of basically choosing those school bags and tiffin boxes and that sort of thing. So in the first problem, the required number of ways wearing a pair of pants and a shirt was the number of different ways of occurrence of the following events in succession. So we had basically in the first problem where we wanted to find different ways of wearing the pants, the different ways of wearing a pair of pants, for example. And of course, when I say a pair of pants, that's how you talk about, well, a pair of pants in English. That doesn't mean that it's basically two items of clothing. It's just one item of clothing, meaning that you have basically, of course you already know this, but this is called, of course, done a little bit better than this. This is called a pair of pants. A pair of pants, right? This is just one item of clothing, not two, meaning that you, of course, you use the word pair to refer to this item of clothing, but nonetheless it's just one item of clothing, and of course you already know about that. But well, so when basically we were talking about the different ways of wearing a pair of pants and a shirt, and so basically the required number of ways of doing so was the number of different ways of the occurrence of the following events, of the occurrence of the following events in succession. Basically, when it comes to these chapters, like for example permutation and combination, each and every one of these sentences and each and every one of these words need to be understood. Otherwise, you will not understand the concept. If you don't understand the concept, you will not understand mathematics. That's the problem. Otherwise, so basically the required number of ways of doing so was the number of different ways of the occurrence of the following events in succession. So the event of choosing your pants, or the event of choosing a pair of pants, and number two, the event of choosing a shirt. The event of choosing a shirt. So that was the first problem, the first example. Now in the second example, the required number of ways was the number of different ways of occurrence of the following events in succession, which was basically, so the number of different ways in the same way, in the second problem, the required number was the number of different ways of the occurrence of the following events in succession. Okay, so we said that in the same way, in the second problem, the required number was the number of different ways of the occurrence of the following events in succession, which was basically one, the event of choosing a school bag, the event of choosing a school bag, number two, the event of choosing a tiffin box, and number three, the event of choosing a water bottle. So here in both the cases, the events in each problem could occur in various possible orders. So the order of these events is not, so this sentence is important. So here in basically both the cases, the events in each problem could occur in various possible orders. But we have to choose any one of the possible orders and count the number of different ways of the occurrence of the events in this chosen order. But we have to choose any one of the possible orders. We have to choose any one of the possible orders and count the number of different ways of the occurrence of the events in this chosen order. What that means is that, for example, in the second problem, for example, you can basically you have 3 events happening here in succession. For example, you have the event of choosing a school bag, you have the event of choosing a tiffin box, you have the event of choosing a water bottle. Now you could, for example, start with the school bag, and then you can choose, after that you can go with the tiffin box, or after that you could go for the water bottle, and then once you've chosen the water bottle, then you can choose the tiffin box. Or you can start with the water bottle, then choose the school bag, then choose the tiffin box. In any order that you basically take these events in succession, it doesn't matter it doesn't really matter in what order you take these events. The only thing that matters is that you have to choose one possible order, and then based on that chosen order, then calculate basically the required number, which is all the different ways that these for example, items can be chosen together, right? So that's basically the main point in this part. And so now this chapter is basically for the most part it has to do with, for example, it has to do with basically all the typical problems in this chapter are about, for example, making up basically words using different letters, or for example making up different numbers using different digits and that sort of thing. So as an example, we have example number 1, which is basically find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose where the repetition of the letters is not allowed. So you want to find the number of 4-letter words with or without meaning meaning that basically you can basically arrange the letters in any way that you want, with or without meaning, which can be formed out of the letters of the word rose out of the letters of the word rose, where the repetition of the letters is not allowed. Where the repetition of the letters is not allowed. Okay, now in order to understand the question is you want to find the number of 4-letter words, meaning that the words that you want to make are basically the number, the word has to have 4 letters, with or without meaning. So with or without meaning is that since you're basically using the letters of the word rose, R-O-S-E, since you're using these 4 letters here, of course you can basically, for example, you could start with an O and then a a R, an R, for example, an S and E. That would be basically one possible word that you can make with these 4 letters. And of course, as far as we know, this word does not have any meaning. It's probably not an English word. It doesn't have any meaning in the English language, as far as I know. So now so basically the question is telling us that it doesn't matter whether the word that you make has any meaning or not. Basically the goal is to arrange these letters in different ways to create different words. Now, what you're actually doing is that you have R, O, S, and E, right? So, and of course repetition is not allowed. So now what you're doing is that since you have these letters over here, R, O, S, and E, you can of course, for example, start with an R. So there is only one way of choosing an R, right? Then after R, you can, for example, go for an O. And then after O, you can basically go for an S. After S, you can go for an E, and then you will end up with rows. Then after that, for example, you could go with, for example, R, for example, SOE. Then you can do basically all kinds of different things. But oh, sorry, my explanation was not correct actually. So what you're doing, basically, you're making these 4-letter words. So you have basically, what that means is that you have 4 vacant places to fill. You have 4 vacant places to fill, right? So when you start, you have R, O, S, and E. You have R, O, S, and E. So what that means is that, and when we say that repetition is not allowed, when we say that repetition is not allowed, what that means is that, for example, when you start with the first basically slot to fill, you have all the 4 letters over here, and you can choose from these 4 letters. That means that suppose that, for example, you can start with any of these 4 letters, meaning that you can start with an R, you can start with an O, you can start with an S, and you can start with an E. Now, once you have chosen R, then of course you cannot choose R again because repetition is not allowed. So then you can choose O, or you can choose S, or you can choose E. And then once you have chosen O, and basically now you have chosen R and O, so then you can choose either S or E. So then suppose that, for example, you can choose either S or E, right? And so you can choose these over here as well. So you can choose either S or E. Now over here, you can after S, what you can do is that basically you have chosen R, you have chosen O, you have chosen S, R, O, S. So the only basically choice that remains is basically E, because repetition is not allowed. So then you will get basically R, O, S, E. Over here, basically what happens is that you have chosen R, O, E, so the only choice that remains is S. Over here, since you have chosen R and S, since you've chosen R and S, then the only thing that remains is, okay, so now basically the rest of this problem. So for example, here you have chosen R, you have chosen O, and then the only thing that remains is S and E. So again, you have basically, over here you have chosen R and S. So the only thing that remains is O and E. So you can choose either basically O, or you can choose E, for example. Over here you have chosen R and E, so the only thing that remains is O and S. And then over here, basically now you have chosen R, S, O, and so the only thing that remains is E, for example. Over here you have chosen basically R, S, E, so the only thing that remains is O, basically. Is O. Over here you have chosen R, E, O, so the only thing that remains is S. Over here you can chosen R, E, S, so the only thing that remains is O. So if you think of this as the first, basically as the first letter of the word, you can see that you can see that basically the first letter of the word, so the word is supposed to be a 4-letter word, right? And we have 4 letters here. So you can see that the first letter of the word, which would be basically this column here, can be filled in 4 different ways. This can be filled in 4 different ways. Meaning that you could choose either R, you could choose either O, you could choose either S, or you could choose either E. All of these are available to you. But then, since repetition is not allowed, as you go forward, you will lose basically, you will lose one of your choices, because you have already chosen one of these letters. No matter which one you choose, you have already lost that one. So then you will get basically then, relative to each of those choices, you have basically 3 choices available to you. So the relative to each choice here, the next letter can be chosen in 3 different ways. Now when you get here, basically you have chosen already 2 of the letters out of the 2 letters. That means that the only different choices that you have is basically you can fill this letter holder, if I may call that. You may fill this letter holder in relative to each of these choices. You have two choices left to you. So you have two basically choices left to you. And then once you get here, you have already chosen 3 letters already, meaning that, and you have basically 4 letters in total. So that means that there is only, relative to each of these 2 choices, there is only 1 choice that you can make. So that is basically 1. So now based on the principle of multiplication, based on the principle of I don't know what the name was, basically based on the fundamental principle of counting. So then based on the fundamental principle of counting, you can say that basically so in the fundamental principle of counting, we said that we said that basically if an event can occur in m different ways, if some event can occur in, for example, the event over here is that the first letter of this word can occur in 4 different ways, right? So this, the event of choosing a letter for as the first letter of this word can occur in 4 different ways. So we said that if an event can occur in m different ways, following which another event can occur in n different ways, and then we said that we could also generalize this concept to n different events basically occurring in succession, meaning that following this event some other event can occur in p different ways, following this event some other event can occur in q different ways, and so on and so forth. Then the total number of occurrence to the events, to all the events in the given order, would be basically the number of ways that this event can occur, which is 4 times the number of ways that this event can occur, which is basically in this case 3, the number of ways that this event can occur, which is equal to 2, and the number of ways that this event can occur, which is equal to 1, which is equal to 12 times 2 is equal to 24 different ways. That means that you can basically arrange these letters R, O, S, and E in 24 different ways. You can arrange these letters in 24 different ways in such a way that you don't repeat anything, right? In such a way that you don't repeat anything. If you could repeat, then of course it would be different, meaning that, for example, if you could repeat, then for example, the situation would be different, meaning that if you had, for example, the same situation R, O, S, and E, these 4 letters, then basically for the first letter of the word, or from the very left, basically for the first letter of the word, this letter here, you could choose either R or S or O or S or E. Now since you can repeat, there is no problem here. So you have already chosen R, but since you can repeat, it doesn't matter. Again, you can choose either R or O or S or E. Then again, since you can repeat, you could choose again R or O or S or E, right? And again, relative to each of these 4 choices, you would have basically either an R or an O or an S or an E. So that means that relative to basically this first letter holder, if I may call it the letter holder, you have 4 different ways of choosing letters here. Over here again, relative to each of these choices, you have 4 different ways of choosing letters. Again, relative to each of these choices, you have 4 different ways of choosing letters. And again, relative to each of these, you would have 4 different ways of choosing letters. And then again, based on the fundamental principle of counting, you could say that if an event, for example, can occur in m different ways, following which another event can occur in n different ways, for example, following which another event can occur in p different ways, following which another event can occur in q different ways, then that would be equal to 4 raised to the power 4, which is equal to something like, I don't know, 16 times 16, which is 36, 3, 9, 0, and 16. That's 256. That is 256. That is 4 raised to the power 4, which is the same thing as 16 raised to the power 2, which is equal to 256. So there you could actually make 256 different words, right? there you could make 256 different words. But then over here you could make only basically 24 different words. But of course there is a problem here, and of course none of these would be actually the same basically. If you think of these words as a string or something like that, there is no way that anything, you're not repeating anything actually, meaning that, for example, as the first choice you have R, 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 R. As the second choice you have R, 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 O. R, 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 O. As the third choice you have R, 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 S. R, 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 S. So that means that in effect, basically you're not repeating anything, meaning that it's not possible that basically if you count the number of words as 256, that you could, for example over here, that you could get basically two of this one. You would get only of this R, 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 R. And of course, for example, R, 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 O, you would get only one of this, not more than one of that. So in this, basically, using basically if repetition was allowed, then you would get, for example, 256 different words. If repetition was not allowed, then you would get only 24 different words, right? And basically understanding this is key to understanding basically this concept properly is key to understanding, I would say, the whole of mathematics, because this concept lies at the very foundation of mathematics. So as the solution here, there are as many words as there are ways of filling in 4 vacant places by 4 letters to solve this problem, not this one. We are not concerned about this one right now. So to solve this problem, you can say that basically over here there are as many words as there are ways of filling 4 vacant places by 4 letters, right? Keeping in mind that the repetition is not allowed. So that's basically what we have assumed. And the first place can be filled in 4 different ways by any one of the 4 letters, following which the second place can be filled by any one of the remaining 3 letters in 3 different ways, following which the third place can be filled in 2 different ways, following which the fourth place can be filled in just one way, right? Thus, the number of ways in which the 4 places can be filled by the multiplication principle is 4 times 3 times 2 times 1, which is equal to 24. And hence, the required number of words is 24, right? So that's basically the whole story here. And of course, well, we will go through enough examples in order to understand this concept. And I assume this, I wanted this to be just a review, but we can actually spend some time on this concept because it's important. Okay, so the next problem here is example number 2, that says that given 4 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other. So basically you have 4 flags of different colors, meaning that you have basically four flags of different colors. Four flags of different colors, and you want to know how many different signals can be generated, how many different signals can be generated if a signal requires the use of two flags, one below the other. If a signal requires the use of two flags, one below the other. So that means that, for example, if you have, let's say that you have four flags of different colors, you have all of these four flags over here, and let's say that this is one color, this is another color, this is another color, and this is another color, and using these four colors or these four flags, you want to create you want to generate these signals, and these signals require that basically two of these flags are put one below the other. So that means that basically you have some situation like this. So it's again basically the same problem as we had before, that we had, for example, the letters, for example, ROSE. We have the letters ROSE, and using ROSE we wanted to build these words, basically four-letter words. And so we calculated, for example, the number of different words that we could make using these four letters if we were basically, for example, building words of four letters each. Now this is the exact same situation here. You can, for example, imagine that basically the problem says that, for example, you are supposed to put the flags one below the other. You could imagine that, for example, in the signal that you generate, first you put the first flag over here, then you put the second flag over here, and you have four different flags over here. So you can take these, for example, as, for example, four different letters, and these are basically two of these four different letters to generate a word which contains only two letters, as opposed to the previous example where the word basically contained four letters, right? So what you can do is again the solution is very simple. So you have basically one placeholder and another placeholder here to fill, meaning that you want to fill basically this placeholder. Also you want to fill this placeholder. So what that means is that when you start here, you could use, for example, any of these four colors, meaning that you could use the first one, the second one, the third one, and the fourth one. So there are four ways of filling this placeholder. And if the repetition is not allowed, of course, I don't really know if repetition is or is not allowed. But if repetition is not allowed, then, for example, you would have three ways of filling this placeholder. Meaning that, suppose that, for example, one of these colors is green. So you use green over here in order to fill this placeholder. So then green is already taken. So you have these other 3 colors to fill this other placeholder. And so then the second placeholder can be filled with only 3, can be filled in 3 different ways, not in 4 different ways. And so what that means is that 4 times 3, based on the principle of based on the principle of the fundamental principle of basically the fundamental principle of, what do you call it, multiplication, let's say, the fundamental principle of multiplication, that is basically 4 times 3, which is equal to 12. And the solution here is that there will be as many signals as there are ways of filling 2 vacant places in succession by 4 flags of different colors. So the upper vacant place can be filled in 4 different ways by any one of the 4 flags, following which the lower vacant place can be filled in 3 different places in 3 different ways by any one of the remaining 3 different flags. So hence by the multiplication principle, the required number of signals is 4 times 3, which is equal to 12, which was pretty simple. Now let's do another example here. Example number 3 is how many 2-digit even numbers can be formed with the digits 1, 2, 3, 4, 5 digits can be repeated. Okay, so the question is how many 2-digit even numbers even numbers can be formed from the digits digits 1, 2, 3, 4 and 5, 1, 2, 3, 4 and 5, if the digits can be repeated. If the digits can be repeated, right? So you want to create 2-digit even numbers. So a 2-digit even number, is basically a number that, of course, first of all, it has 2 digits, right? And then the ones digit of that number is supposed to be an even number, because if the number is supposed to be an even number, the ones digit is supposed to be an even number. So that means that the ones digit is an even number. That means that the number is either, for example, it could be, since you're basically allowed to repeat your digits, so then that means that if you take any of these digits in the tens, basically this is the tens placeholder, or the tens digit. Now, what that means is that if any of these numbers, if you use it in your tens digit, again you're allowed to use the exact same number of numbers in the ones digit, because you can basically repeat your numbers, right? So what that means is that basically there are basically 5 ways of filling this placeholder, meaning that it could be a 1, it could be a 2, it could be a 3, or a 4, or a 5. So there are 5 ways of filling this placeholder. And this placeholder, you can fill it in, for example, one and only two different ways, because the 1's digit is supposed to be an even number, otherwise your number wouldn't become an even number. So there's only two ways of filling this placeholder. So by the principle of multiplication, I'm not sure if the name is right. Let me see. The fundamental principle of counting, I'm sorry. By the fundamental okay, so then I suppose you got basically the total number of basically two-digit even numbers that can be formed using these 5 digits would be then basically 5 times 2 would be 5 times 2, or 2 times 5, 5 times 2, which is equal to 10 numbers. Or basically that's the signal consists of 2 flags, 3 flags, 4 flags. Now let us count the possible number of signals consistent. So we have basically all of these. Now let's go through a couple of these exercises as well. I mean, it's not possible really for me to go through each and every one of these, because I'm I'm doing this basically for a second time, and I mean, whatever is necessary for us to understand the concept, I will do it. Otherwise, I'm not going to do each and every one of these things over here, because that can take a long time. So for example, as I've gotten into basically exercise 7.1 that says how many, for example, and number 1 is how many 3-digit numbers can be formed from the digits, for example, 1 through 5, assuming that repetition is allowed and repetition is not allowed. For example, this is a typical good question that we can solve. So for example, if you want to know how many 3-digit numbers can be formed, you want to know how many 3-digit numbers can be formed. From basically from the digits from 1, 2, 3, 4, and 5. And assuming that the repetition of the digits is allowed and is not allowed. So of course you know that basically you're making these 3-digit numbers. So if you're making these 3-digit numbers and you have basically 5 digits here. So what that means is that then if repetition is not allowed, then you have basically to fill this is the 1's place, this is the 10th place, and the next one is the 100th place. So the 100th place, if you want to fill it, you have basically, there are 5 different ways of filling the 100th place, because, well, the 100th place is you have basically 5 different digits, so you can use the 5 different digits to fill this placeholder, and that's basically 5 different ways of filling the 100th place. So there are 5 different ways to do that. Now, if repetition is not allowed, then of course you've chosen one of these digits over here, right? So since you've chosen one of those digits over here, then you have 4 digits at your disposal. So there would be 4 different ways of filling this placeholder using those remaining 4 digits. And again, the ones digit can be filled in again in then 3 different ways, because first, basically, when you wanted to fill this placeholder, you got one of the digits, and then you got another one of the digits, meaning that you got another 1 digit here. So all the way up to here, you got 2 digits. So 2 digits you got over here, and you have, in total, you have 5 digits. So 5 minus 2 is equal to 3. So there are 3 ways of filling this placeholder if you don't want to repeat anything. And then basically then you can say that the total number of ways that you can, the total number of numbers, the total number of basically 3-digit numbers that can be formed from these digits, assuming that repetition is not allowed, would be 5 times 4 times 3, which is equal to 120, I suppose. That's 20 times 3 is equal to 60, is equal to 60. That's 20 times 3 is equal to 60. So that would be 60 different numbers. Now, the second part of this question, again, you have the same digits here, 1, 2, 3, 4, and 5, and you want to make it these 3-digit numbers, and these 3-digit numbers are of course supposed to be made from these digits, and we know that this time repetition is allowed. Repetition is allowed. So if repetition is allowed, so that means that there are, 5 ways of filling this placeholder. Again, since repetition is allowed, there are 5 ways of filling this placeholder. And again, 5 ways of filling this placeholder. And so all the different ways of filling, basically, or filling all of these placeholder, namely making 3-digit numbers using these digits, would be basically 5 times 5 times 5, which is equal to 5 cubed, which is equal to 125 times 5, I suppose is, 25 times 5 is equal to, that's 25, and that's 125. That's 125. Sometimes you make mistakes. So 5 times 5 times 5 is equal to 125. So that's basically that. Or let's do another example. So how many, for example, 3-digit even numbers can be formed from the digits 1 through 6 if the digits can be repeated, for example? This is also a typical question. How many, they want to know how many 3-digit even numbers can be formed from the digits 1, 2, 3, 1, 2, 3, 4, 5, and 6. If the digits can be repeated. Can be repeated. So if the digits can be repeated, so you want to create these 3-digit numbers, and you want to create them out of these 6 digits, right? So and you want your number to be an even number. That means that the one's placeholder has to be an even number, and repetition is allowed, because it says that if the digits can be repeated, right? So that means that if I start from this placeholder, I have basically 6 different ways of filling this placeholder. again, repetition allowed, I have another six different ways of filling this placeholder. But when it comes to this placeholder, I have only 2, 4, and 6, meaning 3 ways of filling this placeholder, because these numbers are even numbers, and if the ones placeholder is not an even number, then the number is not going to be an even number. So in order for the number to be an even number, the ones digit has to be an even number, and so for the ones digit, I can choose from only 2, 4, and 6, which is basically this, which would be this situation over here. So then all such numbers made from these digits would be, the number of them would be 6 times 6 times 3, which is equal to 36 times 3, which is equal to, that's 90 and 1808. You would get 108 numbers. 108 numbers. And let's do another example here. I want to do as many examples as we can. Or for example, let's say that the question is how many 4-letter code can be formed using the first 10 letters of the English alphabet if no letter can be repeated. So you want to know how many. Okay, so then basically then we have another question that says, for example, how many 4-letter codes you want to know, for example, how many 4-letter codes can be formed using the first 10 letters of the English alphabet. Using the first 10 letters of the English alphabet. If no letter can be repeated. No letter can be repeated. Okay, so you have these 4-letter codes, and you have 10 letters of the English alphabet. Using those, you want to build these codes. So that means that there are 10 ways of filling this placeholder. You have, since you cannot repeat, then you have 9 ways of filling this placeholder, 8 ways of filling this placeholder, and 7 ways of filling this placeholder. That's 90 times. That is basically all the different codes that you can make using this. Using basically these 10 letters would be would basically be 10 times 9 times 8 times 7, which is the same thing as 90 times 56, and 56 times 9 is equal to 450, and then 54. So that you have 504, and you have a 0 there, so that's 5040. 5040. So what that means is that basically the first 10 letters of the English alphabet, meaning that you have, for example, A, B, C, for example, D, E, F, for example, G, H, I, J, K, and so 1, 2, 3, 6, 9, and 10, right? So all the way up to J, you have 10 letters here. So that means that then you can, basically the first placeholder here, you can fill it with any of these letters. Then the next placeholder, you have to exclude that from your from the letters that you can use, and then use the next ones. Then again use the third placeholder. You need to exclude the two ones, basically the two letters that you have used over here, and then put another, basically 8 of them here, and so on and so forth. And so in the same way you will get 5040 basically codes here. And or for example, as another example, you want to know how many 5-digit telephone numbers, 5-digit telephone number, how many 5-digit telephone numbers can be constructed using the digits 0 to 9. If each number starts with 67 and no digit appears more than once. If each number starts with 67 and no number appears more than once. So no number appears more than once means that, for example, since you have these 5-digit telephone numbers, that means that, for example, first of all, your number starts with the 67. So that means that the 67 is fixed here. This doesn't change. And so then you have all you have to do is fill these 3 placeholders. And so since no number can be repeated more than once, that means that, for example, you're not supposed to use, so of course I'm not supposed to use either a 6 or 7 anywhere here, right? Because 6 and 7 have already been used in the number. That's what I'm assuming. I'm not sure if my assumption is right. But based on what I read here, that says that no number appears more than once. Then I would assume that I shouldn't basically use 6 or 7 from these numbers anywhere in these 3 placeholders. Which means that I have 10 digits here. So I'm going to just exclude 6 and 7 from these numbers. So I'm going to then be left with 8 digits here. So I have 8 ways of filling this placeholder, and then any digit that I use here, I'm not supposed to use it here. So then that would be 7 and 6 ways of filling these three placeholders. And so these 3 placeholders are, there would be basically, so what that means is that there is only one way when you have a 6 over here and when you have a 7 over here. There is only one way of filling this placeholder. There are 8 ways of filling this placeholder, 7 ways and 6 ways. So the total number of 5-digit telephone numbers starting with 67 is basically 1 times 1 times 8 times 6 times 7 times 6, which is equal to 56 times 6, which is equal to 336, so that's 336, I suppose. I'm not sure if that's the right answer. Yeah, that is actually the right answer. Okay. Or let's say that, for example, you have a coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? That's a good question. So you basically, a coin is tossed 3 times. How many outcomes are there? How many possible outcomes are there? Okay, so the way that you can solve this problem is that, so the first time you toss a coin, the second time you toss the coin, and the third time you toss a coin, and then there is actually that's actually the kind of question that I had, because in the chapter related to probability, we found out that basically when you toss a coin 3 times, for example, the number of outcomes would be 2 raised to the power 3. 2 raised to the power 3, which is equal to 8. If you toss the coin 2 times, the number of outcomes would be 2 raised to the power 2, which is equal to 4, and so on and so forth. Meaning that if you toss the coin 5 times, then you will get 2 raised to the power 5, which is equal to, I suppose, I don't know, 8 times, for example, 4 is equal to 32, right? Now, what's important here is that basically why that happens. Now, the first time that you toss the coin, you have basically over here you could get heads or tails. That means that there are 2 ways of filling this placeholder. Here you could get basically either heads or tails. Here you could get either heads or tails, and here you could get either heads or tails. So that means that there are 2 ways of filling this placeholder, 2 ways of filling this placeholder, and 2 ways of filling this placeholder. So the total number of outcomes, you would calculate it by multiplying 2 times 2 times 2, which is equal to 2 raised to the power 3, which is equal to 8. Now I understand why basically that happens, and that also is kind of the reason why, for example, you get in the decimal number system, not in the decimal, but in the binary number system, there is all of these numbers. For example, you get, if you have, for example, 10111, for example, as a binary number, you write this number as, for example, basically this is 2 raised to the power 0, 1, 2, 3, and 4. So this is 1 into 2 raised to the power 4, I suppose, and over here you write 0 into 2 raised to the power 3 plus 1 into 2 raised to the power 2 plus 1 into 2 raised to the power 1 plus 1 into 2 raised to the power 0. And what that means is that the place value here is 2 raised to the power 4. And I mean, the same thing happens in the case of the decimal number system. For example, when you write, for example, 10567, This is the ones, tens, hundreds, thousands, and 10,000. So this is 10,000s place value, which is 10 raised to the power 4. This is 10 raised to the power 3. This is 10 raised to the power 2. This is 10 raised to the power 1. And this is 10 raised to the power 0. Now, but well, this is something different. I'm not going to confuse ourselves, but basically, that is basically why you get 8 different outcomes as a result of tossing the coin 3 times, and the answer is to number 5 is basically 8 outcomes. And number 6 is, the question is, given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags, one below the other? Okay, so you have 5 flags, and you want to build these. You want to build these codes, each consisting of basically 2 flags. Now one below the other or one beside the other, doesn't really matter. So So now here I'm just going to assume that I'm not repeating anything. So let's say that this is basically one flag, this is the other flag. I mean, this is one placeholder and this is another placeholder. You put one flag here and one flag here, and that becomes a code. Or you could imagine that, for example, you put one flag here and one flag here, that becomes a code. In any case, in total I have 5 flags. So if I'm not repeating anything, I have five ways of filling this placeholder and 4 ways of filling this placeholder, which would be 5 times 4, which is equal to 20 codes in total, if I'm not repeating anything, which is the right answer here. So, which is actually the right answer here. Okay. Now the next topic here that we have is permutation, that we will talk about in the next video. See you in the next video.